Hello students, myself Janil. We were discussing stability of slopes. This is video part 2. In previous video, we have already discussed types of slopes like infinite slopes and finite slopes, as well as different type of failures of slopes and field applications of slopes. Let us move forward in the same topic. Stability analysis of infinite slope. Now, if you remember infinite slope, we talked that if a slope is very long in the distance and you cannot see full height of that and you cannot measure total easily by with your eye total length, so it is an infinite slope. Let us analyze this. Suppose AB line is an infinite slope line, and if I am assuming a small strip having width B, breadth B and depth Z. So at Z depth, what will be its stability? So basically its inclination angle is assumed as I. For an example, it is small I. If the angle is small I, then the element across the length B will be B into cos I. So we can write down this horizontal length of prism. If we assume it as a prism, the horizontal length will be B into cos I. If I calculate volume of prism per unit length, if it is per unit length, so it will be Z into B into cos I. If we want to calculate its weight, let us assume weight as capital W. Then weight will be gamma into volume, right? And volume per unit length was Z into beta into cos I. So weight of the prism will be gamma Z B cos I. Now you need to understand gamma Z. Here let us see this triangle. Gamma Z, that is Z depth stress at depth Z. Now sigma Z is acting like this in vertical gravitational direction. Now if I see an angle I here, the same inclination angle I here, then it will be in two components. First component, that is sigma, and second one is tau. So sigma can be written as sigma Z cos I and tau can be written as sigma Z sin I. Now, if I am writing sigma Z as W by B, means weight by breadth, then it will be gamma into Z into cos I. Now, we know sigma is equal to sigma Z cos I and tau is equal to sigma Z sin I. Putting sigma Z value in both the equation of sigma and tau. So I am getting sigma as gamma Z cos square I and tau gamma Z cos I into sin I. Do remember both of these formulas, it will be useful. Sigma and tau. Sigma is equal to gamma Z cos square I and tau, that is gamma Z cos I into sin I. Fs, factor of safety, will be tau F by tau. You need to remember that from previous lecture. Let us move to cohesion less soils. Now, if the soil is cohesion less, basically strength of any type of soil will be calculated by tau F at failure strength will be C plus sigma tan phi. Now, if we see a graph, we can see shear stress versus normal stress graph here. If we see Mohr Coulomb strength envelope, then it will be having some angle phi with the horizontal, and if your graph is going above that, means your graph is going above strength envelope, then it will be an unstable slope, and if your graph is going downwards or below the strength envelope, it will be a stable slope. Let us assume it tau F is equal to C plus sigma tan phi and C is equal to 0 because it is a cohesion less soil. Then tau F will be sigma tan phi. Here, if we do sigma by tau ratio, Then sigma value here from previous slide we can understand it is gamma z cos square I upon gamma into z cos I into sin I. Calculating it, it will be cos I by sin I and it will be a cot I. Then we can say sigma by tau will be constant and it will depend on only I, that is cot I. I is angle of inclination. Now let us write sigma is equal to tau into cot I from this equation. Making sigma a subject, we can write sigma is equal to tau into cot I. Same way tau can be written as sigma into tan I. Now we know that Fs, factor of safety, is equal to tau f by tau. So tau f will be sigma tan phi upon tau will be sigma tan I. Sigmas will be cancelled and factor of safety for cohesion-less soils will be tan phi by tan I, which is for dry soil. For limiting equilibriums, when it is a limiting condition, or we can say tau f will be tau. So mobilized shear strength or shear strength will be same as at the time of failure. Then it will be tau f is equal to tau. So at tau f is equal to tau, we can write tan phi is equal to tan I. We just understood this. And so we can write phi is equal to I. So we can also say that when I is equal to phi, the slope will be stable. That is why I have wrote stable slope here. And if I is less than phi, then factor of safety, which will be greater than 1, and slope will be stable. If if I is greater than phi, angle of inclination is greater than the phi angle, then it will be a unstable slope. So moving forward to submerged soils. If a soil is submerged, then its unit weight will be known as gamma dash. So let us write sigma is equal to gamma dash z into cos square I and tau as gamma dash z cos I into sin I. It is nothing new, but gamma is replaced by gamma dash due to submergence of soil. Moving further, for factor of safety, tau f by tau. Here tau f can be written as value of sigma, that is gamma dash z into cos square I into tan phi upon tau, that is gamma z cos I into sin I. So Fs will be tan phi upon tan I for submerged soil. So this is factor of safety for submerged soil. In previous slide we have understood it was factor of safety for dry soil. Let us move to steady seepage along the slope. Now the figure is showing us a steady seepage along the slope. So along the slope there will be some seepage, some pressure is getting like this, and we are showing seepage pressure as U. Others, angle of inclination I, prism width B, all are same, but the thing is new, which is U, that is steady seepage, which is shown by gamma W into Z into cos square I here. Let us understand this. If I want to find out weight of the prism, then it will be gamma saturated into Z into B into cos I. Here gamma is replaced with gamma saturated. Why? Due to this seepage. So sigma Z will be W by B. Now W value, we know that gamma saturated into Z into B into cos I. Dividing it by B, I will get gamma Z as gamma saturated into Z into cos I. Now putting this gamma Z value in sigma and tau. Here sigma is equal to sigma Z cos I, tau is equal to sigma Z into sin I. Here sigma Z value is gamma saturated into Z into cos I. So sigma and tau can be written as gamma saturated Z into cos square I and tau can be written as gamma saturated Z into cos I into sin I. So these are the equations for steady seepage along the slope. Let us write sigma dash is equal to sigma minus u. From very initial chapter soil water, we can get this equation given by Terzaghi. Here sigma can be written as this equation, gamma saturated z into cos square I, minus u can be written as gamma w z into cos square I, where u is what? Pore water pressure. Now deducting pore water pressure from total stress, I will get sigma dash as gamma saturated minus gamma W into Z into cos square I, and gamma saturated minus gamma W will be gamma dash. So we can write sigma dash as gamma dash Z cos square I. Moving further, we can write factor of safety tau f by tau as gamma dash z cos square I into tan phi upon tau can be written as gamma saturated z into cos I into sin I. Now deducting z values we can get, and cos I values we can get gamma dash tan phi upon gamma saturated tan I. So factor of safety for steady slippage will be Fs is equal to sigma dash tan phi upon sigma saturated tan I. Do remember all the factor of safety formulas as well as sigma and tau formulas. Let us move forward to another theory which is for cohesive frictional soil. That means C dash phi soils or C phi soils, which is having C and phi both values. So this graph is showing shear stress versus normal stress values here. Here failure line is shown by this blue line, this intermediate blue line. If I is greater than phi, then it will be a failure like this. If I is equal to phi, it will be stable. And let us move technical stuff. F is equal to tau f by tau. If it is cohesive frictional soil, there will be no C is equal to 0 or there cannot be phi is equal to 0. So I have to consider tau f is equal to C plus sigma tan phi. Putting sigma and tau values from very basic equations, sigma as gamma z cos square I and tau as gamma z cos I into sin I. Here factor of safety F can be written as C plus gamma into z cos square I into tan phi upon tau value will be gamma z cos I into sin I. Further, dividing both terms individually, we can write like this, and the right hand side term will be converted into tan phi upon tan I. Ultimately, at critical depth, we can say critical depth at the depth where it will be unstable after that. Let us assume that depth z is equal to hc, that is critical depth or critical height. There will be tau f is equal to tau because of failure. There can be an equation written, that is gamma into hc into cos I into sin I is equal to c plus gamma into hc into cos square I into tan phi. It is very simple. I have equaled both the equations. Here hc value can be extracted by hc is equal to c upon gamma into tan I minus tan phi into cos square I. So this value, this formula should be remembered as critical height when it is C phi soil. Now making C upon Hc into gamma a subject of the equation, we can get C upon gamma into Hc as tan I minus tan phi into cos square I, and C by gamma Hc, that is a dimensionless quantity, and it is assumed as stability number, which is also known as Sn. So we can write Sn is equal to C upon gamma into Hc. So here two new things are there. First we have learned critical height and second one is stability number. Moving forward, two factor of safety Fc with respect to cohesion. So Fc is equal to C by Cm. We know that from previous video. Now we can also write Cm is equal to C by Fc. It is very simple. Cm is the mobilized cohesion at depth h. Here Cm, we know that there is mobilized cohesion. Now if it is at depth h, we can write Sn is equal to C upon gamma into Hc. That is what we have derived, is equal to, if it is same height h, then Cm upon gamma into h, and it is also written as C upon Fc into gamma into h. This is all mathematical fundamentals. These are mathematical derived formulas very simply. Moving forward, now we can write this equation in terms of tan I and tan phi from previous slide. Tan I minus tan phi into cos square I. That is stability number, what we have assumed. Now it is also mathematically can be compared as C upon gamma into Hc is equal to C upon Fc gamma into h. From that we can derive a very simple but basic equation, that is Fc is equal to Hc upon h. Now it includes cohesion and critical height both. So it is very important for numericals. Fc is equal to Hc upon h. Moving forward to submerged soil case. In this, if C5 soil is there and soil is submerged, then F can be written directly as C plus sigma tan phi, or we can write C plus gamma dash Z cos square I into tan phi upon gamma dash Z into cos I into sin I. Here gamma is directly written as gamma dash because it is submerged soil case. So let us move forward and divide it both by gamma dash z cos I into sin I individually. By dividing that, I will get right hand side term as tan phi upon tan I. Now defining critical height Hc can be like this: C upon gamma dash tan I minus tan phi into cos square I. It is very simple. Now, if the case of steady seepage along the slope is there, we know what is that from previous 5 minutes. Here, F is equal to written as C plus gamma dash Z cos square I into tan phi upon. Be careful here, gamma saturated Z cos I into sin I. It is case of steady seepage where we will use gamma dash in numerator and gamma saturated in denominator. Dividing both by the same term, we can get right hand side as gamma dash upon gamma sat into tan phi by tan I. Now defining critical height Hc as C upon gamma saturated into tan I minus gamma dash tan phi into cos square I. These are mathematical terms. Let us move forward for the case of purely cohesive soil. In purely cohesive soils, there will be phi is equal to 0. And from chapter shear strength of soil, we can remember that it will be a straight line if we draw a graph versus shear stress versus normal stress. Now here tau failure will be governed by C only due to cohesion only, because strength will be governed by cohesion because it is purely cohesive soil. Let us move further. I is the angle of inclination and this is my failure point in the graph. Technically, we can write F factor of safety as C plus gamma dash Z into cos square I into tan phi upon gamma dash Z into cos I into sin I. If Z is equal to Hc, that is critical height, if we want to define critical height, we can write gamma into Hc into cos I into sin I as C. C is cohesion here. Now Hc can be written as C upon gamma cos I into sin I. So we defined Hc critical height. If we want to define stability number Sn, Sn can be written as C upon gamma into Hc. We know that very well from previous 5 minutes. Here C upon gamma Hc can be written as cos I into sin I, putting Hc value, that is very simplified form. Or we can also say F is equal to hc by h again. So that's it for this lecture. We will continue this chapter from next video. Thank you.